Hello, let's see how we can solve this one here. This one is a bit tricky. Yeah, it's a bit advanced. Yeah, but it's a good one for exercise. This is the setup. We have a ball at an angle of 35. Then we want to determine the initial velocity so that this ball uh, hits a target 30 meters away. Therefore, we need first of all to sketch this diagram in Creo. Let me open up Creo here. I'm going to use meters as the units, set MKS, that cross. Then I'm going to insert, you can say ball. Let's use the default now for now. I'm going to use default constraint and open up this. As well, change units to be MKS. Yeah, set that and close this one here. And let's revolve a ball, quick one here. That if you want to learn how to design in Creo, just watch my videos there. Yeah, I have explained I've used some of examples for you. Yeah, that's my ball. Yeah, yeah. Let's create a point at the center. That, and you can give it some appearance if you want. Yeah. Okay. Going back to the assembly, I should see my ball there. Then let me activate the plane here, and on the front plane we need to create the sketch here. You see this profile 30 at 1.8 by 35. We have that. This one is 30 1.8. Yeah, 1.8 there. Then we have 35. This is 35. Just this length doesn't matter. Just want to show it just for the direction. Then this is what we are looking at. Let me just create a curve here from this point. Just a small curve to present just for fun. Yeah, like that. Therefore, we have a ball here at this point, and we are aiming to draw it to a point here. I want to see what is the initial speed here. I want to see the velocity, yeah, so that this ball can hit this point. And this one we have seen is 30 and 1.8. That's my ball. We're going to draw the ball, and we want to determine the velocity we need so that this ball can follow this curve and destination to be this point. Therefore, let me drop a point here. Oh, it's not there. Yeah. Yeah, I've dropped 2 points. Delete the first one. Yeah, like that. The first thing we need to do, we need now to define, uh, to give this ball some degree of freedom. And by the degree of freedom, I mean it's supposed to move on this plane only. Therefore, we're going to use what we call planar degree of freedom. If you go to the planner just need to state which two planes you want them to have a degree of freedom. Just that. Therefore, my ball can move on this plane like that. Then we want this ball starting point to always be here. Okay? We want the starting point to be this point here. Therefore, I'm going to define the initial point, that is this plane to this plane, another one, this plane to this plane. This is my initial point. Initial point. That. Therefore, if you view from this side and hide the planes, if you move your ball around like that, you want this ball to go to the initial point, select like that. It is our launch point where we are going to start. Now, for this ball to go this direction, it will have the force of gravity acting against it. Because we don't know V naught, we can assign a value of the force you use to draw the force. Because we know the force will introduce velocity, we can assume a value. For now, we can go to tools, go to parameter, we can create a parameter, we call it maybe draw force like that, the force we are drawing with, and you can give it a random value like 1,000. Doesn't matter, because I'm going to assume that force, we're going to apply a force this here to draw the ball until it lands this point. Therefore, if you go to mechanism now, remember we said the initial condition, my initial point, fine. Then, now listen very carefully. Because we don't know velocity, we can estimate the force needed. If I select force, I can say at this point, I need a force, but now, you see I've selected axis. You have to select this point, datum point, like that point. This is the point I need. And this point here, this point, you have to define the direction. Remember, force is a vector quantity. Any quantity, you can see force here, you have to give direction. How do you know now these directions here? Because you have to give vector direction. When you say 1, for example, when I say 1 there, 1 means x-axis. When 1 means y and x becomes 45. Therefore, you have to determine this vector first. Quick way, you can determine this vector. Let's go back to now design here. The vector, I can edit the sketch. I can drop a coordinate system here, like that. Or even I don't need to drop a coordinate. I don't need to do that. I can just drop a point there and drop my coordinate here and align this to be. In fact, let me just show you another quickest method you can use. Just create just one line and ensure this line and these two lines are perpendicular. You can give it any value dimension. You can say maybe 0.5. Just a difference. Okay, and this point drop it here to this point instead. Okay, therefore go back to coordinate, drop it onto this point and reorient x-axis to be this one here, y-axis to be this, and flip x as well. And now you have this one here, coordinate system that I can use to determine the transformation matrix. For you to move from this point here to this one here, you can determine what we call transformation matrix by going to analysis, go to transform. You want to transform this to this. Therefore, you press Ctrl, you're transforming this to this, and this is the matrix we need. When you apply this matrix transformation, it will take you there. Therefore, let me copy this screenshot, because we just need to define that in our mechanism so that we can get this vector. Remember, we said we need to align our motion to this vector. Go back to force. Remember, I said the datum point. Now we're going to assign these values 0.81952, 0.819152, 0.573576, but for the z-axis 0. You see now my vector is parallel to this line. You can see the arrow, it points to the x-axis. Therefore, if you transform this, you get that arrow. For the force, not a constant, we're going to say user defined, and we're going to add the one we defined as a, remember we said we're going to use a parameter that is called draw force. This one here. Now the draw force, okay, like that. That's my draw force. Let's say okay. And my force here, let me just give it some name. The draw force, like that. Therefore, this is the force I'm going to draw with. Gravity is there. You can see the gravity downwards. Initial conditions we had already defined here. Initial conditions. Then I'll show you how to use termination. But for now, let's just continue. Let's do measure. We want to measure what? I'm going to create 3 measures. First measure is velocity. I can say v naught, but I want to see if I draw this body with that draw force, what is the initial velocity there? I can say maybe at time t equals 0.1 initial, because I'm going to use step of 0.1. Therefore, I have to say at 0.1 of this point, that point, ball point, yeah, like that. Another measure I want to measure is x value, position of this point here, x component. That another measure is y value of this point here, or y component, vertical direction. For now, let's measure those: velocity, x and y. If I'm going to analysis, we're going to perform dynamic analysis. We said we're going to use a 0.1. Let's for now use 20 seconds. Initial condition there. Go to external load. Draw force. Start, then add 0.1. We're going to assume you're going to draw your body within 0.1 seconds. And you have to enable gravity and say okay. Let's see what happens when you run. runs very fast. You see what happens now? My ball is going downside. Okay, you can if you change here to 10 seconds like that, you can do another run. Yes, still the ball is continuing. You can see this line. This line means the ball is going on this direction, but we need to say the ball need to stop. This is the ground. Need to stop in the ground. That is what we call down the termination. If you go to the x value, y value here, you see the y value, the ball goes up, then starts to go to negative side. We need to ensure that the ball does not go this direction. Therefore, I will say when the y measure is 0, when it's 0, you can stop the analysis. Or I can say when the x value is certain value, x equals 30. You can go back to here. We said when x is 30, the ball is supposed to be here. Therefore, I'm going to use x30. Let me see the x values here. X value is increasing. Let's now say when x is 30, termination condition. This one here, parameter x, when x is 30. When x is 30, be my termination condition here. You can give it a name if you want. Go back to analysis and assign termination condition 30. If you now run your analysis, the ball should stop there. See, it stops there. You can see now my ball stops exactly at x equals 30. The task we have now is to ensure that this ball is supposed to stop at this point. Okay? Therefore, I'll show you one of the ways you can solve that, but we are not going to get accurate results because of, remember, we are using a 0.1 time step, and that 0.1 time step here, this one here, and our load is 0.1, it will contribute because our V naught here is 1.1, and you can see we defined at 0.1. Yeah, but I want just to show you the concept on how you tackle this type of questions. Remember the parameter we defined here, draw force. If you reduce this draw force maybe to 500 like that, and run the analysis, go back to analysis, run, you see the ball stops. But now it will continue because it have to stop when x is 30. You can see where it stops when x is 30. Therefore, you have to determine which value of that force will make this ball stop here. You can see it is trial and guess. When you say 800, let me see what happens to 800. Almost there. It is almost there, but we need to get it accurately. Therefore, I can see 800 is almost there. Now I know 800 is almost there, but I need to get a very accurate value. Let me just go back to my initial value here. Let me now do another run this analysis again, like that. It goes there. This is what we call a parameter we can create. This point and this point is this distance here. This distance is called separation distance. Therefore, we can go to mechanism, measure, and we can say, let's measure the separation here is between, and we can say what separation between this point and this point, and say okay. Therefore, if I now do another analysis now, if I go to measure this between, I see 6.91, 6.913. Therefore, the distance between this point and this point is 6.193. Even I can confirm that by measuring here from this point to this point. Press Ctrl to this point. You can see 6.913. Basically, what we need to do is to ensure that this distance of separation equals to 0. Okay? Equals to 0. Let me show you how you do that now. Once that becomes 0, we're going to get our accurate, our V naught here, and we're going to see from our question here, we are supposed to find the time taken here. We are saying time taken for this bar to move to here. We're going to see the time taken and which velocity. Time taken and velocity. Therefore, we're going to move out of mechanism, don't save, and we're going to do what we call analysis, motion analysis. The reason I said this one is a bit advanced because we have about 7 analysis we can do. We can do UDA, user defined analysis, motion, Creo simulate, ergonomics, relation, Excel, and external analysis. We're going to do motion because we have a motion here for the design study. Next, remember the distance between, for that. You can see now the separation distance, how it is reducing from 30 to this point here. But we want to get exactly 0. Okay, I can now pull that minimum. I want the minimum, this minimum here, this between, this min here, to be 0. This minimum distance between to be 0, like that. Now I have created a parameter that is called minimum distance here. You see, mean distance between. That's a parameter I wanted to create so that I can vary that parameter. Go back to analysis. Now I can go to sensitivity analysis. I can now perform that draw force. If I change this draw force from 0 maybe to something like 1500, how does my parameter mean distance vary? Let's see. I can say now when I change the mean distance between reduces then increases, meaning for me to get 0 I need to get between 600 and 1000. Let me go back here, 600 and 1000. Compute again. Okay, I'm almost there. This one is because of the steps we talked about. It seems I will get 0 because here it is 1. I will get 0 eventually between 600 and 1000. Okay, therefore let's go back here, close. Let's do what we call visibility. Let's add a parameter, draw force here. From 600 to 1500, and to vary what? This minimum distance between to be 0. Like that, and compute. We are computing now. We have found a solution. And see, now the ball is exactly there. Let's see the error. Preferences, run. Let's use a 0.00 error to be more accurate. Compute again. Okay, you see now we have a new value of parameter. Let's go to parameter. We have 794. If I apply a 794.85 force, my ball will move exactly there. Let's go into the mechanism to validate this. Let's go here and run this mechanism again. Exactly. You can see it is moving exactly. Yeah. And if I go to the distance between, I should see 0. See, it's almost 0 here. And you can see, let me see my V naught. Let's change this V naught. At time this one here. This one is supposed to be velocity. Velocity. Yeah, no wonder. Perfect. Let's see our V naught. Let's first see the X. You can see now we were able to cover our X 30 in 2 seconds. You see here the graph. Graph states 2 seconds. 2 seconds. That is when we cover 30. Therefore, the time taken to move from this point to here is 2 seconds. That answers our second question. What's the time for the ball to reach the target? It answers that 2 seconds. Because now we have seen, when you check the X direction of the analysis, also it will give you 2 seconds here. We just squeeze it down for you. You see here we're getting 2 seconds. This 2 seconds to cover 30. And that is the total length. Now velocity 18.43. We are getting 18.3. You can see we are almost there, but not accurate. That's the velocity. You can see the V naught here. We said V naught, it is at the time 0.1. That's our V naught 18.43. That is how you can solve this type of question by using a parameter to help you vary the parameter to get velocity. Hope you have learned something. Thank you and stay tuned for more.